Okay, guys, recording the vodcast for homework 3.7p. So we're going to be doing 3.7p, and I want you to notice this problem is taken directly from the 2007 AP Chemistry examination. So it is a very recent problem. It's one that is very applicable to what we're doing. And I'm using the document camera again to record this. I'm trying to get better at using this camera. So if anyone has problem with this vodcast, please let me know and I'll do it on my other device. So this first question, notice they gave you a big box, and they're always going to give you boxes for the Lewis structures. So when you see those, it might be an indication to you to go and do that problem. So the first question says, in the box below, draw the Lewis electron dot diagram, same thing as a Lewis structure, for the IF3 molecule. Okay, so what I'm going to do is I'm going to use this side of the box for my scratch work, and then I'm going to draw it neatly in the box. So we know that I has 7 dots, and we know that all the F's have basically the equivalent of 1 dot. Now we're on a free response problem, so we will draw those later. So I'm going to reach out to this. I'm going to split, and I'm splitting to a single bond, so I am allowed to do that. Okay, there it is. I'm then going to draw my I in the middle. I'm going to draw my F. I'm going to draw my F. I'm going to draw my F. And I'm going to draw my lone pairs on the top. Since I'm on a free response problem, I'm going to draw my lone pairs on the F to make it look nice and neat. Okay, now it doesn't ask us for the shape of this molecule, but it might later on. So let's go on to the next problem. It says, on the basis of this diagram, predict the molecular geometry. Okay, so we see 3 things attached. And we know if there's 3 things attached, it's either going to be trigonal planar, it's either going to be trigonal pyramidal, or it can be this thing called T-shaped. So this one is actually going to be T-shaped. Okay, and that's because of the presence of those 2 lone pairs. If there was 1 lone pair, it would be trigonal pyramidal. And that's all they ask. Why don't we go down here and look at a couple more things with this? Let's identify sigma first. Sigma is going to be 3. There's those 3 connections. Pi is going to be 0. And the hybridization is going to be 1, 2, 3, 4, 5 things. And if there's 5 things, sp3d. All right. That's the hybridization of the I. Remember, hybridization only pertains to the central atom, whereas this is all bonds. All right, let's go down to this next one. In the SO2 molecule, both of the bonds between sulfur and oxygen have the same length. Explain this observation, supporting your explanation by drawing in the box below. Okay, so we have a box. The Lewis structure. So let's draw the Lewis structure first. Let's do it on the side, and then we'll do it a little bit later on. So SO, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Attach, attach. Okay. Looks like we hit a dead end, and our first instinct is to split. But we cannot split to a double bond. Notice, this would be like splitting to a double bond, and we cannot do that. So we're going to shift. I'm going to take this electron, I'm going to put it down here. It's going to free up the other one to bond there. Therefore, the Lewis structure is going to look like this. Okay? Now notice that this Lewis structure could have been, I'm going to use double-sided arrows to show you this, I could have just as easily have done my shift on the other side and ended up, sorry, there's only one lone pair here, and ended up with a Lewis structure that looked like that. Okay, notice there's no difference between these two. The only difference is in one, the double bond is here, and in the other, the double bond is here. Okay, and this process is called resonance. Okay, and resonance is simply when a double bond can move. Okay, so the double bond can move. And in C, they're basically asking you to explain this. And the reason that the sulfur-oxygen bond length is the same when there's a double bond here and a single bond here is that the double bond can move, so it's equally distributed. So the answer, to justify it, you could say, because of resonance. That's it. Okay, so let's go down to D, then I want to go through this one more time. On the basis of your Lewis diagram, identify the hybridization of sulfur. Okay, well, let's do everything again for sulfur. Okay, let's do it right here. Sigma for the whole molecule, sigma is going to be 2, pi is going to be 1, and hybridization, how many things are around each of these? 1, 2, 3. Remember, we do not count pi bonds in hybridization. If 3 things are around, it's sp2. So that's sp2, and that is sp2. Now, both of these are different representations of the same thing. So, I want to go over this whole thing one more time, and I really, really want to focus on C. So if we look at this first one, we see a box. They ask for the Lewis structure of IF3. They ask us to predict the geometry. It's going to be something other than planar. If you said pyramidal, I bet they'd give you credit. But we're going to go with the T-shaped here. It pushes it even farther away from a pyramid. See, a pyramid would be up here even a little more. This extra lone pair really pushes it into that T-shaped position. Went through and just said that there were 3 sigma, 0 pi, and the hybridization was sp3d. Don't do that on the real test because you want to have as much time as possible. We go on to this next problem. They said to draw the Lewis structure for SO2. We saw that we hit a dead end here, and we didn't split, we shifted, because you cannot split into a double bond. When we did it, we noticed that the double bond was on the O, but it could have easily been on the other O. And when you get across a situation like that, that is called resonance. Resonating that the bond can move around. There are 2 structures, and we use these double-sided arrows to show both structures. The reason the sulfur to oxygen bond length is the same on both sides is because of resonance. This double bond can move around, so basically the average of both of these is the bond length. Just copy down what I wrote right now. Okay guys, have a great day.